This is AP Calculus Study Guide 110617. What I did is I put together what I call a study guide for what we've covered so far this semester. Now, this is not everything, but a great deal of the concepts that we taught this year so far. And just if we understand these things, we're in pretty good shape. Okay, this first one, use the table below to answer problems 1 through 3. A particle's velocity is given in meters per second in the table. And usually there'll be more description like this represents a continuous function or maybe differentiable. But question number 1, what is the minimum number of times the particle had to be at rest? Justify. Well, for a particle to be at rest, okay, for a particle at rest, velocity has to equal 0. So v of t is equal to 0. So what we're looking for are places that the velocity has to be 0. Well, if we go along at time, we can see between t equals 5 seconds and 7 seconds, the velocity went from 1 meter per second down to negative 5 meters per second. And so somewhere in there, the velocity had to be 0. And the way we articulate this in calculus, we say, I'm going to write this to the right, give room. According to the IVT, which is abbreviation for intermediate value theorem, there must be, okay, between 5 and 7 seconds, and also between 10 and 12 seconds, because we went from negative 8 meters per second up to 1 meter per second. So we say there must be at least 2 times, okay, because now the numerical justification, because 0 is greater than v sub 7, right? At 7 seconds, velocity at 7 seconds, and so 0 is greater than velocity at 7 seconds, but less than v sub 5. So we've identified one interval, and 0 is also sandwiched between v sub 10 and less than v sub 12. And we can see what those numbers are and why 0 is between those. So this type of notation really narrows down where those zeros have to occur and the justification with intermediate value theorem for them. Now, number 2, what is the minimum number of times the speed of the particle had to be exactly 4 meters per second? Well, this tests the same type of thing, but with a twist to it. What it is velocity equals absolute value of speed. Absolute value brackets, so that's speed. So anyway, if we look at it this way, we would have to have exactly 4 meters per second. It would have to occur here between 2 seconds and 5 seconds. But also, since the absolute speed is the absolute value of velocity, we have to look for wherever the velocity is negative 4 seconds, or has to be negative 4 seconds. Well, we see it's also going to have to happen between 5 seconds and 7 seconds. If we go from 1 meter per second down to negative 5 meters per second, and also between 10 and 12, where we went from negative 4 meters per second up to 1 meter per second. So we say, I'm just going to say, according to intermediate value theorem, there must be at least 3 times and now the interval justification, because four is, let me see, it's going to be greater than v sub 5, but less than v sub 2. And now the other intervals, and let's see, how should we say this? 4 is less than the absolute value of v sub 7. Does that make sense? Because absolute value of v sub 7 is going to be 5, but greater than the absolute value of v sub, let's see, v sub 7, v sub 5. Okay, and then 1 minute interval, and between 10 and 12 seconds, 4 is less than the absolute value of v sub 10, because that's will be 8, and then as 4 is greater than the absolute value of v sub 12. Okay, not too terribly legible. Okay, use the data in the table to estimate the acceleration of particle at t equals 11 seconds. Show correct units. So here we have 11 seconds between 10 and 12 seconds. And so the estimate of acceleration is going to be the average rate of change between these 2 points. So it's going to be estimate of acceleration is going to be equal to the average rate of change of velocity. So we've used f of b minus f of a over b minus a. So we could say b is equal to 12 and a is equal to 10. So estimate of a of 11, meaning acceleration of 11 seconds, equals f of b, which is 1, minus negative 8 over 12 minus 10. And if we simplified, 1 minus negative 8 will be 9 over 2. Can't show correct units. We're going to have meters per second squared. So that's it. Those are problems 1, 2, and 3. 4. If h of t equals 2t over sine t, what is the equation of the line tangent to the graph of h of t where t equals 3 pi over 2? So we want to find the equation of tangent line. The things we're going to need are twofold. We're going to need a point and the point we have input value, I was going to say x value, but we have 3 pi over 2. And our y-coordinate, we don't have that yet. We'll have to locate it. We'll be able to do it here in a little bit. So, let's just plug that in. We'll say h of 3 pi over 2 is equal to 2 times 3 pi over 2, replacing t here in the numerator, over sine 3 pi over 2. Now, one thing that the sine of 3 pi over 2 is going to be negative 1. So we're going to have 2 times 3 pi over 2. We're going to get 3 pi. And then sine of 3 pi over 2 is negative 1. So we're going to get negative 3 pi as our output value. So negative 3 pi. There we have our y-coordinate. Now next, we're going to need to have a slope. Well, for a slope, we have a quotient of two functions. And so the organizing technique that I show my students is the high function we're going to identify as 2t, and the derivative of high function is going to be equal to 2. And for the low function, we have sine t, and the derivative of the low function is equal to cosine t. Okay, so now we can find the derivative of this function, h prime of t is equal to the low, and our low is sine t, and then derivative of high times derivative of high, which is 2, minus the high function, which is 2t, times the derivative of the low, which is cosine t. I'll just write it like that. Okay. And that over low squared. So instead of sine t, we're going to have sine squared of t. And can we simplify this at all? Yeah, we can, but we're just going to put in, we'll say h prime of 3 pi over 2. So what we have here is sine, I'll say 2 sine 3 pi over 2 minus 2, and t is 2t, so it's going to be 2 times 3 pi over 2 times the cosine of 3 pi over 2. Well, the cosine of 3 pi over 2 is equal to 0. And we already established that the sine of 3 pi over 2 is negative 1. And we're dividing all this by sine squared of 3 pi over 2. And we know that sine of 3 pi over 2 is negative. So what that's going to simplify to is, since cosine 3 pi over 2 is 0, we can just cross out in red all this that is 0. And we have 2 sine 3 pi over 2. And it's going to be 2 times negative 1. And then we've already zeroed out this one here with the red. And then we're going to have negative 1 squared. So that's going to simplify to negative 2. So that's going to be h prime of 3 pi over 2. And this is going to be our slope, which I'm going to call m sub t. So we had our point here, and so now we have our slope. M sub t equals negative 2. So our equation of our line is going to be y minus negative 3 pi, so we're going to say y plus 3 pi equals negative 2, which is our slope, times x minus our x coordinate, which is x minus 3 pi over 2. And so that's going to be our equation for our line. So quite a few things. The quotient rule, the derivative of trigonometric ratio, finding a tangent line. So quite a few things there. 5, if g of x equals 2x squared cube root of x, what is g prime of 9? Now this one could be done in different ways. One way this could be looked at is a product of two functions. We have this, if we look at this 2x squared, and then we look at this cube root of x and treat them as a product of functions. That's one way to do it. Another way to do it, which is what I really prefer to do in this case, is to consider this as g of x equals 2x squared, and then take this cube root of x and realize that that's simply x to the 1/3 power. And so what we're going to have is 2 times what we're going to have is 2 times x, and we can write squared as 6/3 times x to the 1/3. We're going to get 2x to the 7/3 power. And now g prime of x is equal to, we're going to take this fraction 7/3 out front times 2 and we're going to have x to the power of 7/3 minus 1. Well, 7/3 minus 3/3 is 7/3 minus 1, so that's going to be x to the 4/3 power. And just kind of putting these together, we're going to have 14/3. 17 times 2 is 14 over 3. X to the 4/3 power. And so that's going to be g prime of x. And we can also write this as 14 thirds. We're going to have the cube root of x to the 4th power. Or you can put 4 on the outside, whatever. So g prime of 9 is equal to 14/3. And we could figure out y to the x to the 9 to the 4th power. That would be quite large. I think what happened here is I think I intended to use 8 because a cube root of 8 would be 2. So I'm just going to leave it like this. I'm just going to leave it just like this and not elaborate further. So we'll have 9 to the 4th. So that's as simple as I choose to make at this point. 6, for function f of x equals 3 square root of x, what is the average rate of change in the interval 1 to 25 seconds? So it'll be just like we have the AROC formula, which is going to be f of b, we already talked about that earlier, minus f of a over b minus a. So we'll say b is 25, we'll say a is 1. So for that, we're going to have f of b is going to be 3 square root of 25 minus 3 square root of 1. And that's going to be all over 25 minus 1. And just simplifying, we're going to have the square root of 25 is 5. So 3 times 5 minus 3, and 25 minus 1 is 24. So we have 15 minus 3, which is 12 over 24, which is equal to 1/2. Now, again, according to the principles of the AP test, I really didn't need to simplify beyond this first thing here, 3 times 5 minus 3 over 24. So, but that's our answer. 7, for the function f of x equals 3 square root of x, was the instantaneous rate of change where x equals 9. Well, again, we're using the same function, but looking for different things. Instead of average rate of change, we're looking for an instantaneous rate of change. And to do that, we're going to say, okay, how do we find that? Well, to find instantaneous rate of change, we need to find the first derivative. So before putting f prime of x, I'm going to say f of x is equal to 3x to the 1/2 power. And then f prime of x is equal to 1/2 times 3 x to the negative 1/2 power, which, kind of simplifying, we're going to have 3 in the numerator over 2 square root of x. And then f prime of 9, we're going to have 3 over 2 times square root of 9 So that's going to be 3 over 2 times 3, and 3 over 3 cancel each other, so we have 1/2. So this was totally accidental, but it so happens that this instantaneous rate of change where x equals 9 is equal to the average rate of change over the interval from 1 to 25 in the same function. This is what's called the mean value theorem, which we haven't covered yet. Okay, for 8, for the function fx equals 3 square root of x, what is the equation lying tangent to the graph of fx where x equals 16? So we can do the same thing we did earlier. We had, I'm just going to transcribe, f prime of x is equal to 3 over 2 square root of x. Okay, and now at 16, f prime of 16 is equal to 3 over 2 times square root of 16, which equals 3 over 2 times 4, which equals 3/8. So that's going to be our slope. We'll call this m sub t. And then for the point, well, point is going to be x equals 16, and y equals, well, we don't know yet, f of x. So we say f of 16 is equal to 3 times square root of 16, which equals 3 times 4, which equals 12. So our y-coordinate here is 12, and slope is m sub t equals 3/8. So what is the equation of our line? It's going to be y minus y1, which is 12, equals our slope, m, which is 3/8. We have x minus x1, which is 16. So that's it. 9. What is the limit as x approaches 4 of fx? And I kind of didn't write this right. I shouldn't have put f of x. I should have just said, I should have written that function in the place of f of x. So I just crossed that out as kind of a correction. So now what we're going to do is substitute in 4, and if we substitute in 4, we get 4 minus 4, and then we're going to get 4 squared minus 2 times 4 minus 8. And so it won't take a lot of arithmetic to figure out that we have indeterminate 0 over 0 situation. So now we're just going to try to factor this. So if we take x minus 4, we can assume that since we have 0 over 0, we must have below this a factor of x minus 4 in the denominator. And then what do we multiply by x minus 4 to get x squared minus 2x minus 8? That would be x plus 2. And x minus 4 over x minus 4 cancel, and we're left with, I'm just going to put the limit stuff here now. Limit as x approaches 4 of now 1 over x plus 2. And now substituting in for x, we have 1 over 4 plus 2, which equals 1/6. So that is our answer. And next, problem 10, same thing. I made the same type of error. It's not limit as x approaches infinity of f of x. It's in place of f of x is this function. And what we're going to have here is you have to, in the limit as x approaches infinity, that's going to be what's called a horizontal asymptote, which I abbreviate HA. So what we have to look is the biggest terms. So what we have is we have the cube root of x to the sixth power over 3x squared. Well, the cube root of x to the sixth power, and we take the biggest term below, which is 3x squared. Well, the cube root of x to the sixth, that's going to be like the power of 6 times 1/3, is going to be like x squared over 3x squared. So our answer to this is 1/3. So we would just say equals 1/3, or we can similarly say the horizontal asymptote is, we can say, now we can just use f of x, right? Limit as x approaches infinity of f of x, which we would say that is 1/3. Or we could say y equals 1/3 would be our horizontal asymptote. Next, 11. Find the values of a and b which make the piecewise function differentiable. And so differentiability also includes continuity as part of its universe. So first of all, we're going to take care of the continuity. And to do that, we will use this notation. Limit as x approaches -1 from the left side of this function f of x equals the limit as x approaches -1 from the right side of f of x. And then we can just start writing this out. From the left side, we have b x squared minus 1. And the right side, we have ax plus b. And so just plugging in -1, we'll say b times, on the left side, b times -1 squared minus 1 equals a times -1 plus b. And just simplifying, this -1 squared is just 1, so we have b on the left side minus 1 equals -1a plus b. And b minus b on each side, they will cancel each other. So we have -1 equals -a. And so we end up with a equals 1. So what we're saying is that really doesn't matter what b is here, that we're going to have continuity no matter what b happens to be, since they subtract, I guess, because they cancel on each side. So, but now we gotta look to another thing for differentiability, which is not the limit as x approaches infinity of, x approaches -1 from the left side of f of x, but rather of f prime of x. And that would have to equal the limit as x approaches -1 from the right side of f prime of x. And so we're just going to take the first derivative. So we take the first derivative of bx squared minus 1. We're going to have 2bx. And the derivative of negative 1 is 0, so we don't even have to write that down. And on the right side, this ax plus b, well, we're simply going to have a, and b goes away. And then if we substitute in negative 1, we'll say 2 times b times negative 1 is equal to a. So on the left side, that's going to be negative 2b equals a. Well, we already know a equals 1, so we can substitute in 1 for a. So we have negative 2b equals 1, and dividing by negative 2, we have b equals negative 1/2. And then we can, if we substitute back in, we can see that that would be the case. Negative 1/2. Yeah, because b would cancel out on each side. Wouldn't matter what that is. So that would work out. Anyway, that's that problem. 12. If h of x equals tan x minus x cubed cosine x, what is h prime of x? Well, for this, we need to know some trigonometric differentiation, and one of which is the derivative of tangent x equals secant squared x. And then we need to know the derivative of cosine x. That's going to be less problematic. So anyway, h prime of x is equal to the derivative of tangent x, which is going to be secant squared of x, secant squared x, then minus, and now we have this product of two functions here, and it's going to be a product of x cubed, and the derivative of x cubed is 3x squared, and then cosine, and the derivative of cosine x is going to be negative sine x. And so if we subtract, I'm going to make one big parentheses here. We're going to have x cubed times negative sine x, and that's going to be plus 3x squared cosine x. Okay, so now we should just be able to simplify here. We're going to have secant squared x, and we're going to have minus minus here with this x cubed negative sine x, so that's going to be plus x cubed sine x, and then we're going to have minus this 3x squared, so we have minus 3x squared cosine x. And I think we'll just leave it at that. So that's going to be h prime of x. Again, the product rule, trigonometric differentiation. 13, a particle moves along the x-axis. Position for x is greater than or equal to 0 is determined by the function fx equals x cubed minus 9x squared plus 24x. For what value or values of x is the particle at rest? Well, the particle at rest is going to be at rest where the velocity is 0. So I'm just going to write this down. Particle at rest where velocity, I'll call it v of x, equals f prime of x equals 0. And so finding that first derivative, we'll say f prime of x is equal to 3x squared, and we'll have minus 18x plus 24. And setting this equal to 0, we'll say 0 equals 3 times, we have x squared minus, factoring out of 3, what's that going to be? 6x plus 8. So we're going to have 3 times 0 is equal to 3 times quantity x minus 2 times quantity x minus 4. So to solve this equation, it's going to be either x equals 2, or both x equals 2, and x equals 4. So for what values of x? So we've answered the question at this point, so we can move on now to problem 14. Now, sometimes we're going to say over what interval is the particle moving left or right, and we certainly could do that with the information we have by making a little number line analysis. X equals 2, x equals 4. We'll put v of t here, and position down here, which is going to be f of x. So we could do a number line analysis, but that's another thing. Okay, 14. What is the integral from 0 to 4 of 2 plus 0.5x dx? Now, this is not typically what you'd find in the first semester of calculus course, but this is something we introduced right from the beginning of the year to just get students familiar with integrals, so it won't hit them so strangely later on. And so what you have is a function, and that function is going to be the function y equals 2 plus 0.5 or 1/2 x. So for that, we have a y-intercept of 2, and we're going from 0 to 4. So here's our y-intercept, and we have plus 1/2 x. Well, that's going to be a rise over run of 1 up 1 over 2, and then up 1 over 2 again. So we're going to have this kind of graph here. The maximum height is 4, and what we have once we fill this out is a shape of a trapezoid. Well, a trapezoid has a height here equal to 4. We have a base called base 2 equals 4. Base 1 equals 2. And so the area is going to be 1/2 the height times b1 plus b2, and that's going to be equal to, our height is 4, and b1 is 2, and b2 is 4, and divided by 2. So that gives us 4 over 2 canceled to be 2 in the numerator. So we have 2 times 6 equals 12. So that is our area. And you could separate this out too into 2 pieces. You could take this piece here, I'm putting in red, find that area, which is going to be this 2 by 4 rectangle, and then this separate area here. That's another way to look at it. Anyway, that's the study guide, and it covers, I think you'll see, quite a bit of what we have gone into this first semester. Good luck. and thanks for viewing.